Situation 4. The concrete column is reinforced using 4 steel reinforcement rods, each having a diameter of 18 millimeters. So we have the Young's modulus of each material for steel and for the concrete. Okay, the column is subjected to an axial load P as shown here in the figure. So we have the dimensions of this column, 300 mm by 300 mm. And we are to calculate the stresses on each material. Okay, so ano yung approach natin dito? Okay, so first, we can just do here summation of forces. Okay, so let me illustrate this one in plain view. So if I will cut dito at this portion or any portion dito, since prismatic naman to, the same dimension lahat all throughout the length. Okay, if I will cut that point, we can expose the forces here. This is the force for the concrete and these are the forces for the steel. By summation of forces vertical, that should be the equation. 4 of PSD or apat na steel, of course apat yung nandito, plus the concrete, force in the concrete should be equals to 800. And gagawin ko siyang newtons. Okay? 800,000 newtons. That should be our equation 1. If we can calculate the PSD and the PC, we can calculate the stresses on each material by just dividing this one to the areas. Okay? So, saan natin hahanapin yung equation 2? Since dalawa yung unknown natin, we need to create another equation. Okay? So, hahanapin natin ito or gagawa tayo ng another equation by using the elongation. Okay? Look at this one. Because of that force, 800 kilonewtons, that will deflect in this manner. Okay? So, of course, mag-e-expand yan sa width niya. Okay? That is, we can calculate that actually by using the Poisson's ratio if we have that one. Okay? But anyways, yung gagawin natin dito is the axial deformation. Okay. Now, this elongation, as you can see, let's call that delta. Now, the elongation of the concrete here, or the deformation of the concrete, should be equal to the deformation of the steel lang. The same sila. Okay, klaro? So, by this one, we can just equate the elongation. Elongation of the concrete, of the steel, is just equals to the elongation of the concrete. The same lang sila. Okay, so take note, we should calculate first the area. Okay? So, the area of one steel is pi over 4 times its diameter. We have 18 mm diameter. So, that is the area of the steel. Now, for the concrete, that should be 300 by 300. Yan yung area ng ating gross area ng ating concrete. But we should minus the area of the steel. Okay? Kumbaga, net area ng concrete yung gagamitin natin. So, minus 4 na area of steel. Okay? That is the area. So, by using this one, using the formula of the axial deformation, PL over AI, ito yun. PST times the length over area of the steel is this one. Young's modulus of elasticity ng steel is 200 gigapascal. But I will not convert na lang this one to MPa. Bakit? Because dito, the same lang din yan. Area is this one, then Young's modulus of elasticity. We don't need to convert na dito or we don't need to multiply this by 1,000 because maka-cancel lang sila in both sides. Okay? Now, as you can see, the length of the initial length of the concrete and the initial length of the steel is equals lang. So, we can cancel this out. Okay? And if I will rearrange this one, it will give us this equation. Okay? I will just, it depends to you paano mo siya i-simplify. But, what I did here is I just cross-multiply this one, whole term dito sa PST. And this one over this value, ito yung 44.71. Yung matitira dito is yung PC na lang. Okay? Kaya, pag transpose natin, maging negative PC, equate to 0. So, by this one, using your calculator, 2 equations, 2 unknowns, and we will have these values of PST and PC. Naka-newtons yan. Okay? So, the stresses of the steel, for the steel is force over area. So, that one, this force, divided by the area of the steel. So we have this answer. Okay. For the concrete, the same manner, force of the concrete then divided by the area of the concrete. And that is the answer. Okay, so madali lang. Okay, so let's have situation 5. This should be situation 5. A rod is composed of aluminum section rigidly attached between steel bronze sections. Okay, as shown in the figure. Axial loads are applied at the position indicated. So we had the value of P here, 3,000 pounds, and the cross-sectional area of the rod is 0.5 inches square. So we are to determine the stresses in aluminum, in the steel, and in the bronze. Okay, so in order for us to calculate the stresses, we need first to calculate the forces in each material. Okay, so how to calculate that? So we can just cut this portion at any portion. We can just do that, but I will introduce to you this axial diagram. Actually, we can use the axial diagram para hindi tayo malito sa forces or when magka-cut tayo. Sometimes kasi nakakalito yung pagka-cut natin. Okay, so first, I will just calculate the reaction dito. So as you can see, this reaction should be ano to? 4P, then P lang yung nandito. Dapat mag-equal sila. So this should be 3P for equilibrium. Okay? So yung axial diagram here, kung meron tayong shear diagram, we have also the axial diagram. Okay? So here, that is tension, yung P natin. Kumbaga, hihilahin niya yung member palayo. So for that tension, that should be upward. Okay? From that point, ito yung 4P natin. Okay? Then, at this length of the steel up to the aluminum, walang axial force indicated dito. So, constant yung axial force natin up to that point. Next, this P, our tension is going to the left. Okay? This P is going to the right. That means that is in compression. Okay? So, please understand this. If yung assumption natin here for tension is going to the left, then our assumption for compression is going to the right. And I will advise you to do that always. Okay? Going to the left for axial diagram, that is in tension. Going to the right is compression. And actually, it depends on you talaga. But for me, I will do to the left, tension, to the right, compression. In this kind of problems. Okay? So, if this is P, compression, or going to the right, or that is opposing to that force, 4P minus P, that will be 3P na lang dito. Okay? That is 3P. Now, from this point up to that point, walang axial force. So, that will be constant at that portion. And of course, this is 3P. Then, ibabalik niya ito sa 0. Okay? Ito yung axial diagram natin. So, to calculate the stress in the aluminum, this is the aluminum. Ano yung force natin dito? That should be 4P. Okay? So, that should be 4. The P here is 3,000 pounds. So, in this problem, we need to convert this into KSI or kips per square inches. So, I will just divide it by this by 1,000 para maging 3 kips na lang. Okay? So, 4P, that will be 4 times 3. Ano yung area? 0.5 inches square. And we have this answer. For the stress in the steel, ano yung force sa steel natin? The same pa rin. 4P. Okay? So, that will be 4 times 3 over the area. And that is 24 KSI pa rin. Now, for the bronze, 3P na lang yung force natin or axial force. So, that will be 3 times 3, 3P over the area. Okay, madali lang, no? So, these all stresses are axial stress. As you can see in this axial diagram, puro positive forces yung nandyan. Okay. So, another situation. The solid cylinder AB and BC are bonded together at B. Okay, so this is a torsional problem. They are bonded at B and are attached to fixed support at A, at this one, and also at C. Knowing that the modulus of rigidity is this one for aluminum, okay, And this one for the brass times 10 raised to 6 yan. Determine the following. Maximum shearing stress in cylinder A, B. This one. Maximum shearing stress in the cylinder B, C. Okay. So first, I will calculate the reaction at each endpoints. Okay. If I will do the free body diagram. Okay, so our basis here is the formula of the shearing stress, the TR over J for maximum. Okay, so we need to calculate the torsional moment on each member. Of course, this one should be distributed sa ating members. Okay, itong external moment or external torsional moment, it will be distributed sa ating member. But how can we distribute that? Okay, so let me call this one as the torsion at BC, and let me call this one as the torsion at member AB. So by equilibrium equation pa rin, that will be torsion AB plus torsion BC dapat equals at 12.5 kips inch. Okay? So another equation, ano yung gagawin natin for the another equation? So take note that the rotation at this point, the rotation of member AB should be equal to the rotation of member BC. Okay, since naka-fix silang dalawa, hindi pwedeng magkaiba yung rotation nila. Okay, you got that? Dito yon. So we can just equate the angle of rotation or theta AB is equal to theta BC. Okay, klaro? So remember this formula for angle of twist or rotation, TL over JG. Okay, so in this member AB, that will be TAB times the length of AB, 12 inches, divided by the J. Take note, J is pi over 32 for circular polygon, times the diameter. So the diameter of aluminum is 1.5 times the G. So our G here is for aluminum, saan yan? 3.7 times 10 raised to 6 PSI. So, ika-cancel ko na lang diretso yung times 10 raised to 6 natin, no? Because both sides meron silang times 10 raised to 6. So, we can cancel out that already. Okay? Para mas konti yung equation natin dito. Then, equate to this one, the same pa rin. TBC times the length, 18 inches, times the rigidity, times the modulus of rigidity, G. I mean, this is the polar moment. Okay? So, actually, you can cancel this out. Pi over 32 dito. Okay? And I will cross multiply this whole term here dito and itong 18 dito sa baba. And this will give us this equation. Okay? You can do na that. The simplification. Okay? So, after this is our equation 2. And grab your calculator. 2 equations to announce. And that are the torsions at each member. So by now, we can calculate these stresses. For member AB, following this formula, TR, so our R is of course half ng ating 1.5 or 0.75 divided by the J, pi over 32 times diameter raised to 4. That is the answer. And for member BC, the same pa rin, 9.52 kips inch times the radius of this one. So that should be 1 inches or 1 inch divided by the J, and that is 6.06. Okay? So, easy. Okay, so another situation. Thermal stress naman. Okay? Thermal stress. A steel rod 3 feet long with a cross-sectional area of 0.25 square inches is stretched between 2 points, 2 fixed points. So, ito yon, naka-fix sila. The tensile force is 1,200 pounds at 40 degrees Fahrenheit. So, we have the Young's modulus of elasticity here and the alpha. Okay? Nakalimutan ko yung term, ano yung alpha. Basta, alpha. Ayun. And you can see in the units dyan. Okay? It depends on the temperature. Now, the temperature, we are required to calculate the temperature at which the stress in the bar will be 10 KSI. And the stress the temperature at which the stress will be 0. Okay. Paano ito i-analyze? Okay, so initially, okay, at this case, in the case yung bar is walang stress, ito yung original, kumbaga, original position natin. Hindi pa to nag-stretch. That when our temperature is 40 degrees Fahrenheit, mag-i-stretch yan. So, it says here that it will induce tensile force of 1,200 pounds. So, kailan mangyayari na magkakaroon ito ng tensile force pag nag-change yung temperature? Ano yung analysis? Okay, so imagine this. When the temperature drops, okay, when the temperature drops, yung material natin will be shrinking or mag-shrink yung material. So, in this case, this rod will shrink. So, ang nangyari dito, as you can imagine, when the temperature is 40 degrees Fahrenheit, that means nag-shrink siya. It will induce a tensile force. Okay, let me call this as our delta due to temperature. Okay, ganito yan. If in case, hindi siya naka-fix dito, this will be freely to shrink yung material natin. It will freely to shrink pag ganyan. Paatras. Because pababa yung temperature. But because naka-fix siya dito, that's the time na hihilahin siya dito sa ating fixed point. Okay? You can imagine that. Magkakaroon tayo ng tensile force dito. And that is the 1,200 pounds. Kaya magkakaroon ng tensile force. Because nga, at initial point, if hindi siya naka-fix, it will shrink pag ganito. But because naka-fix siya dito, hihilahin siya ng ating fixed point. Okay? Kumbaga, ipe-prevent niya na mag-shrink yung ating material. So, that's why yung temperature will cause a thermal stress. Dito mabubuo yung thermal stress natin. Okay? If free lang ito, walang thermal stress na mangyayari. Elongation lang. But because piniprevent ng ating material or ng fixed point na mag-elongate siya, that's the time magkakaroon ng thermal stress. Okay? I hope you got this one. So, this one is the stress, is the temperature when this induce a tensile force of 1,000 pounds. What if yung sinabi is compressive force? Ano yung scenario? So, that should be a rise in temperature. Kumbaga, dapat hahaba yung ating bar para ma-push niya yung fixed point dito. Okay? In this case, tensile siya. Kaya, pag ganito, pa-shrink siya. Pag nag-shrink, that is a decrease in temperature. Okay? Bababa yung temperature natin. Pag nag-increase yung ating bar, that means that is a rise in temperature. Okay? Magra-rise yung ating material if we have a rise in temperature. Mag-shrink yung material if we have a decrease in temperature. Okay? So, please understand this one. So, ang gagawin ko muna dito is I will just calculate first the temperature when the stresses here will be 0 lang. Okay? Kumbaga, walang stress na ma-i-induce. So, how can we calculate that? Okay. So, please understand this. We can just equate the deformation because of the change in temperature, that one, dapat ibabalik siya ng deformation due to this force, the axial force. Okay? Kaya, this is just our main equation. Deformation to temperature minus the deformation due to the axial force dapat equals to 0. Because in reality, wala tayong makikitang gap dito. Okay? Kaya, because nga, piniprevent ito na mag-shrink because it is fixed at this point. Okay? Kaya, ito yung main equation natin. Now, take note that the deformation due to the temperature, the change in temperature is given by this formula. Okay? And for the axial force, we can use this one, stress L over E. Okay? We can just use the other formula, PL over I. But the same na sila. P over A is just the stress. Okay? Now, I will substitute this one dito. Okay, that one. Okay? A alpha L times the change in temperature. This one, ito yon. Now, take note, we have these values. We have the alpha dito. 6.5 times 10 raised to negative 6 times the change in temperature minus, take note that our L dito, okay? Look at this one. The L here can be cancelled out. Okay? So, ma-cancel out natin ito. So, tatanggalin ko na lang yan. Minus, the stress is 1,200 over the area. Okay, klaro? 1,200 divided by the area. Ito. Ang area natin is 0.25 inches square times the E. 29 times 10 raised to 6. Now, as you can see, we can calculate the change in temperature. That is 25.46. And as we analyze kanina, dapat we have a drop of the temperature or decrease of the temperature because nga nag-induce siya ng tensile force. If this is compressive force, then it will induce a rise of temperature. Okay? So in this case, that is a drop in temperature, so we need to calculate the T1, the original temperature when this body has not stress, has not inducing a stress, no? So that will be T1 minus 4T. So we can just calculate the original temperature yung wala pang stress na na-induce sa ating body. That is 65.46. Okay? And actually, ito yung hinahanap sa number 2. Okay, nauna ko lang siyang isolve. We can just simply directly, using this one, diretso-diretso, na gagamitin natin yung initial stress, but para mas maintindihan, ibabalik ko siya sa original position na wala siyang stress na na-induce. That one, T1. Okay? That one. This is the temperature when this body has no stresses. Okay? Now here, for number 1, the temperature when the stress in the bar is 10 KSI. So, hindi siya naka-specify na na tensile. But, this is due to this problem, sa initial statement niya, we have tensile force. So, we need to assume that this is a tensile force. Okay? So, in order for this to have a tensile force, mag-shrink siya. Okay? That one. Kaya, hihilahin siya ng ating fixed point. Klaro? Okay, so we do not know pa this P yet dito. Ano daw yung temperature if the stress is KSI, if the stress will be in 10 KSI. Okay? So, how can we do that? The same pa rin. I-equate natin to or just this one. And maka-cancel yung L dito, no? And again, I will just substitute 6.5 times 10 raised to negative 6. That is the change in temperature. Then, stress is 10,000. Again, maka-cancel yung L natin dito. Divided by E. And we can calculate the change in temperature. And again, if this is a tensile force or nag-shrink siya, dapat yung change in temperature is going down. Okay? So, the stress in this point should be lesser to this original stress natin. Okay? That will be 65.46 minus the temperature at that point. And that is 12.41 degrees Fahrenheit. Okay? That is the temperature when the stress in this body is 10 KSI. And of course, for number 2, the temperature at which the stress will be 0, ito yung inuna natin. Okay? That is 65.46 degrees Fahrenheit. Okay? I hope you understand that. Pag mag-shrink siya, it will induce a tensile force or tensile stress. Pag mag-elongate siya, pag ganyan, or hahaba yung ating bar, it will induce a compressive stress. Because as you can see, mapupush niya yung ating fixed point. Okay? Please understand that. And also understand that when the change in temperature is upward, then it will elongate. And when the change in temperature is downward, then that means it will shrink. Like this one. Okay? Okay, last example. The rigid horizontal slab is attached to 2 identical copper rods. This one. These are identical copper rods. There is a gap, delta of 0.8 in here, between the middle and aluminum slab. Neglect the weight of the slab and use the following data. Refer to this figure. So we are to neglect the weights here. Okay, so calculate the stress in copper, we have the change or increase in temperature. Pag increase in temperature, that means hahaba yung ating mga material. The same lang sila, increase in temperature, 85 degrees Celsius. And we have these data. So, how can we calculate the stresses on each ating materials? Okay, so let me just calculate first the elongation of each material due to this change in temperature or increase. So that will be, for the copper, alpha is 16.8 times 10 raised to negative 6. The length is 750 mm. The change in temperature is diretso na. This is the change already. The rise in temperature. 85 degrees Celsius, and that is that one. For the aluminum, the alpha is 23.1. The length is, of course, that will be 750 minus 0.18. Yung original length yung kino-consider natin dito. Times the change in temperature, and that is 1.472 millimeters. Now, let's analyze this. For example, wala yung ating slab dito. So, these bodies will freely to elongate like this one. Okay, that one. Hahaba yung ating mga material because that is an upward or increase of temperature. So, this one is our elongation of the copper. The same lang dito. Okay, the same lang sila. This one is the elongation of the aluminum natin. Okay? Now, again, this is assume na walang bar or walang slab dyan. But take note, if we have the slab, okay, let's imagine nga na naka-fix yung slab natin dito muna. Ayan. Okay? So, take note, yung slab natin naka-fix at this also, at this copper also. Okay, hindi lang dito. Dapat naka-fix siya sa lahat. That means, it will be hihilahin dito. Okay, this one is hihilahin ng slab dyan. And also this one. And this one is ipupush or magkakaroon ng compressive force dito. Okay, and it will be like this. Okay, just imagine this one. Okay, did you understand that? Hihilahin niya because ayun nga, naka-fix sila. Hindi pwedeng magkakaroon ng gap dyan in actual scenario. Okay, so it will be like this. Okay, so as you can see, this one, that is another elongation, no? That is just another elongation. And let's call that delta 1. And also this one, as you can see here, ito, it will elongate pabalik. And let's call that elongation 2 na lang. Okay? So, ano yung mga elongation na to? Ako, take note, as you can see, if we will refer to this net elongation, we can just equate, ano ito? Delta 1 plus delta C. Okay, let me just do this. Delta 1 plus delta C. And this one is also equals to delta of the aluminum minus delta 2, okay, minus 0.18. The same lang siya dito. Okay, kaya ito yung equation na magagawa natin. So, take note, ano yung delta 1 natin? Ito. That is due to the axial force induced. Okay, you gets? That is just due to the axial force induced dito. Kasi hihilahin siya ng slab pataas. Okay? So, PL over AE. So, that is just the force in copper. PCL. So, L, this is the original length over AE plus that one. Plus the delta C. So, we calculated that. Equate to the aluminum. So, 1.472 minus the delta 2. So, this delta 2 is also due to the axial force induced in the aluminum member. That is a compressive force, no? As you can see. So, that is PL. So, yung L natin dito is yung original length. That is 750 minus 0.18. So, ito yon. Divided by AE. So, our area is 400. Our E is 70 times 10 raised to 3 for megapascal. Minus 0.18. Now, as you can see, we have two unknowns here. So, saan natin hahanapin yung ating pangalawang equation? So, okay. So, analyze this one. Take note that this will induce a compressive force. Okay? Kasi, ibabalik niya yung slab pababa. So it will be this reaction. This is just the force in the aluminum. And this one here, the copper should have a tensile force. Hihilahin niya yung slab pag ganyan. And that is our PC. By this one, summation of forces vertical, we can say that the aluminum force is equals to 2 of PC. Okay? I hope klaro yan. Then I can just substitute this aluminum dito. Okay? That will be 2 PC. And ang mangyayari dyan, yung PC na lang yung magiging unknown. And by this one, we can calculate our PC as this one. And also, we can calculate our aluminum force na dito by just substituting this one to that one, and that is just twice. Okay, therefore, the stress on each member is just force PC, that one, divided by the area of the copper, 500. That is 6.7 MPa, and of course, this will be in tension. And for the aluminum, that will be that force divided by the area of aluminum, 400, and that is 16.7 MPa, and that is in compression. Okay, so that's it.